Hi, I'm Charlie Rigby, and this is my grandpa, Mike Thompson. And what was your profession?
Okay, my profession was structural ironwork. We put up buildings, bridges, and power plants, uh, generally around the Ohio Valley. If we did have to work out of town, we called that booming out, and I've had to do that a few times, but I was very fortunate to work on a lot of buildings, bridges, power plants right here around Cincinnati.
All right. What's your background using geometry?
We had a 4-year apprenticeship from day one going into the profession. I had some experience before that. I knew how to read a tape measure, which is very, very important. I knew how to use a square and stuff like that, but we require our apprentices to pass a math test with some geometry, trigonometry, and by all means know how to read a tape measure. That's very important.
Yep. So, what is required for a first-year apprentice to know about math or geometry?
Part of it, they learn in the classroom. They have to have over 1,000 hours of classroom training per year, and that's only part of it. Then they work out on the job, average probably 40 hours per week on the job, and their training on the job would be from the men on the job, the journeymen, which we call the journeyman on the job, to let them use what they've learned in the classroom. We do structural ironwork, like I say. We have, if it's a small shopping center or whatever, that's usually where we start the apprentices. Nothing that's going to get them up off the ground too far, but there is some height work involved. But just to be able to use the tools that we use, that includes geometry. We have what they call a plumb bob for a straight up and down measurement to make sure that the columns that we set that carries the beams are plumb. We have a tri-square like this that we have to cut something off, maybe with a torch or with a grinding wheel or bandsaw or whatever. This marks 90 degrees. It's adjustable to fit most of the structural members that we use. We also have adjustable tri-squares that will actually change the degrees, and they have to learn like how many degrees in a circle, 360 degrees in a circle or 180 degrees, or if they cut something on a 45, this will actually measure 90 degrees this way, 45 degrees this way. So they have to be able to know the difference, and it's measured off into degrees. Most all measurements that we refer to comes off of engineered drawings or architectural drawings, and that's another thing that apprentices need to learn, even the first year, is how to read structural drawings. That's very important.
So by the time they are ready, they'd be very qualified. How did you use angles on your job?
Angles is just another, structural angles. This would be a structural angle. Angles are all measured off into different degrees, like I just mentioned. We use what we call the 3-4-5 method. It's part of trigonometry, I assume. 3-4-5 method is, if we want to square a building, and we go out with a tape measure and maybe a chalk line, if we go out 3 feet and go over 4 feet, say we go out 3 feet, 4 feet, then we have 5 feet in between. That's a perfect 90-degree square. You can do that 3, 4, 5, 6, 8, 10, 12, 16, 20. You can go for miles, you can go for feet, you can go for inches, what it may be. But that's the perfect way to get a square, to get a base, to get a start for a building. Like I said, when we get on the job, the concrete, the footers, the foundation, everything's laid. when we get on the job with the iron, unloading trucks and stuff with the iron, we go back and check all the anchor bolts to make sure that they are already set to where they should be according to the drawings.
So, like the last question, how did you use shapes to build or weld?
Shapes come in all different configurations. Like this would be an angle. We have channels. We have I-beams that make the columns that the iron sits on. We have structural plate. So many different configurations, and it's all parts of the shapes of the iron that we use. And most everything is on a plane, a straight plane. Sometimes you get into radiuses. This is just a little compass, so sometimes it's in a circle. So, you know, we use circles a lot sometimes that we have to cut maybe in a structural column where we have other beams coming in and stuff that require in the field fabrication. Sometimes we have in the field fabrication instead of like in a machine shop. So what we have to do is lay out a set of holes, you know, for the other beams to come into, so they have to be precise.
Yeah.
And that's where the radiuses come in. That's where the geometry comes in. And it's all apprentices learn that before they get out of apprentice school.
So, how do you use different tools to measure and help you use actual geometry during your job?
Well, like I say, when they first get into apprenticeship, they learn what a tape measure is and what all the lines. Generally, in our line of work, it goes down to 30 seconds. Some of them may go down to 64ths, or if you get into machine shop work, it goes into tenths and thousandths. But we don't do that in iron work that I work with. We get as close as like a 30-second. Most all your buildings and what have you that you're working on, it's already been figured out in an engineering shop, or the architects draw it up in a plan. So everything's got to fit.
Yeah.
So the pre-drilled holes for the bolts and the beams and everything to fit together is already pre-fitted, and the holes are punched in a machine shop and sent out on the job. But we have to go back and make sure that everything is fit according to the drawings. That's why the drawings are so very important.
So, how has using geometry ever applied to you outside of being an iron worker? And can you explain how you use geometry to do these things?
Okay. I probably learned geometry somewhat in high school, which I did, but I really didn't learn it until I come out into the construction field. I worked as a laborer, I worked as a carpenter, and I used those skills enough to where I built my own house. I laid out, you know, the foundations and just about everything. It works with wood, not only just steel, but it works with wood, just about anything. But I learned all that mainly starting out in high school, but it really come to use when I started working construction.
Yeah. So, how did you use? Would you say that you had to use a lot of the geometry when you were like making the plans to build the house, or was it more when you were actually building the house?
Both. As far as the plans to build the house, I already had a set of working drawings that I bought, and I used that. But a lot of times you have to go back and re-engineer something that that you might want to change.
Yeah.
So I learned how to do all that.
So, how important is it to have precise measurements and calculations while you're, say, an iron worker or building your house?
It's very important, and you always want to get as close on your measurements as possible. And sometimes that's not possible. So you have to, on most jobs, you have an architect and you have an engineer, and they're right there on the job, especially bigger jobs. So sometimes you have to you know, you look at the drawings, you go out and you try to measure something up and put something together and it's just not working. You
Yeah.
have to go back to the engineering department and find out, you know, why does it say a certain measurement on the drawings, but it won't work on the job. So sometimes they'll come out with another, like a CSK drawing or something and make a change. So nothing is ever perfect in construction, nothing. It's, but you get as close as you possibly can, and that makes everything work. Your base, the base starting point on jobs is the most critical part, because if that's done right, then everything above there, it could be a 30, 40 story building, all works off the base. You get a good base started, everything else falls right in line.
All right. Thank you for your time.
Okay. Thank you, Charlie.
Thank you.
Good job.
All right, let's